All right, guys, just like I told you I was going to make another video. This is going to be a much, much quicker video. It's not going to be, 10 years off your life or anything like that. It's only, 12 years off of mine for having to create it. Basically, what it is there's something called a dampening of these waves, right? And dampening happens when in physics, when there's some sort of friction that gets in the way. So you have some oscillation. Maybe it's a plucked guitar string or some sort of sound wave or magnetic wave. Any type of wave that's moving along, and it's got to be sinusoidal. It's got to be a repeating wave. So it's got to be that up and down motion, up and down, up and down, and up and down. So we look at that wave, and it continues on, and it oscillates at a certain, wavelength or a certain frequency. You get the idea. It's got a period, and it makes either makes a sound or even watching ripples on the ocean. There are things that can get in the way, and what'll happen is you'll have something that looks a little bit like this guy right here. There's what is called a dampening factor, and when it hits this bit of friction, this is a linear, right? Y equals 2x is a linear function, right? So y, let's use a different color. Sorry about that. Let me get rid of that. So y equals 2x, that's a linear function. And what that does is that's what produces that friction which shortens the wave or slows down the wave and may change the sound or something like that. So it gets dampened. It either softens the sound or changes the pitch because it's been damped down so far, anything like that. But it's hard to graph, but easy to graph all at the same time. Like if you understand what the sine graph looks like, and I'm just going to rough it in here. You see, all you need to do is start with your regular sine wave, right? Your sine wave, and it starts there. And then what you do is you fit it in between the positive and negative versions of that dampening factor, that 2x that's in front of the sine x. That's called the dampening factor, dampening factor. All right. And this is all I really want you to know about it. I don't need you to know how to do it. I can set you up so that you can see what it looks like on a calculator. You'll put in, when you put it into a calculator, you put in this whole function, and then you put in these two as functions, and then it shows you those two lines, and it shows you the wave and how it gets smashed and how these two things touch each other. and it's putting three functions into a calculator and then looking at the graph. You'll see some guys say, well, I want this one to be a thick line because we don't all have colored calculators, et cetera, et cetera. But I just want to show you one quick example of how to draw it, how to rough it. And here we go. I'll move to the next screen. Bye-bye. Hello. Let's use this. Okay, so let's just take this idea, and I'm going to create an axis for it. Give me a second. I forgot to create this first, so let me just create an axis for it. Go from here to here. All right, so now I have an axis. We'll go to actually looking at sine x. Well, sine x is just that simple wave, right? But the first thing you need to do is, and I'm going to create a line using this, is go ahead and graph this as, I don't like that color. Let's use that one, and let's see if I can make it. And this 5x is pretty steep. I'm not going to make it as steep as it really is, but there's 5x, and I'm going to try as hard as I can to make it just as steep on the other side. But if I'm not perfect, please forgive me. That's a little bit better than the other one. Anyway, and so we have 5x. We've graphed the following. We've graphed y equals. Oh, sorry, I'm still in this mode. We've graphed y equals 5x, and we've graphed y equals negative 5x. So if you graph those two things, right, and you have it there, and then you just fit the sine wave in the middle, and this is the hardest part of the whole thing, is just fitting the sine wave in the middle. And that's more like it, and it gets bigger. So it gets smaller, and then it gets bigger again. It ran through that friction and then started again. Because it still has the same frequency. It's still going to keep going. It just runs into a little bit of friction. And it may change a little bit on the other side, but that's basically how you do it. I hope you understand that. I hope you get the idea. The thing that I want you to answer, the questions that I want you to answer are, what is the dampening factor? What would be the dampening factor in a certain function? And you'll just write the dampening factor, y equals 5x, okay? Or whatever it is that's sitting in front of the sine function. I don't need to know about the rest of this stuff. The best way to do it is to use a calculator, because then it's very, very accurate. Other than that, that's all I need you to know. Thank you for taking the extra time to learn this piece. And that's it. And I'll talk to you guys tomorrow.